rates, they are going into a region where they are exposed not only to the solar wind, but also to galactic cosmic radiation. High energy charged particles that can damage the structures of the chips, but also corrupt the data that you have. In deep space, for the outer solar system exploration, it's cosmic radiation that we are really concerned about. Solar wind has diminished as 1 over r squared from an inverse square law. But you are seeing here, some of the trails you are seeing away from the thoriated rods will be due to cosmic rays. So radiation is a real threat for space operations, but also it is an opportunity, because if we want to go into the deep solar system, using solar cells, photovoltaics, becomes useless beyond Jupiter. Mark will tell us more about the Rosetta mission that is the furthest that any spacecraft has gone with enormous solar arrays. And the physics behind nuclear decay that we are seeing from the rods, alpha and beta, is the same physics that we can use for power generation. Radioisotope thermoelectric generators. If we have a radioactive source, we can use the decay products to generate heat. We can use that heat with 2 different metals to generate a potential difference, an electric current. And we are currently doing that for ESA and NASA's Cassini mission that's been orbiting Saturn since 2005. And for the future, for deep exploration of the solar system, it will be radioisotope thermal generators that will be key. ESA has changed its position. It had a long-standing position on RTGs. ESA is now doing a lot of research on RTGs. And so the physics that we see with the cloud chamber is absolutely relevant for both the bad and the good when it comes down to radiation in space. I have been talking for 3 minutes. I think we shall turn the lights down. If you drop your heads, let's have a look. Now, of course, this is a randomly occurring trail. And let's see what trails we get. Looking at the naked rod, and I can see trails already from this one. Oh, you had 3 of them there. Yeah. So it's the naked rod where you will see more trails. It's a little bit like you're looking for a sort of
I'm not sure where they're coming from.
Then where they come from, yeah.
Yeah.
Look at the uncovered rod. If I look from here, you will suddenly see it.
Hard to see where it starts.
Yeah. Oh.
Wow.
Ja, het ja. Ik denk dat die andere die staat nauwelijks.
What you are looking for, then you start seeing more and more of it. Can you see it?
They're very straight as well, so they're all off it. But what's amazing me is the paper dissolves.
Voor de PVK.
Yeah, the paper.
For the naked rod, you should be seeing a lot of.
How do you this is the video? That's Laura's camera actually, so I'm not very familiar. Yes, now it's going. We need to focus first.
Or look from this angle. Wherever the mist is,
Wow. The gas drops.
I wonder if there's too much paper around that rod.
Oh, now it's more visible finally on the camera.
and it will also depend on the energy spectrum of those emissions. Now, for this particular decay, this is the decay route that we're seeing from thorium. So we've got primarily alpha and then 2 beta decays to get back to thorium and then down to alpha. And it's the spectrum of those beta emissions.
Well, you count over time.
Oh, that was a beta. Yeah. Or on this side, is it that or mu one?
Short trailers now. Has anybody seen a completely separate trail away from the rods?
I think we might have, yeah.
Yeah, because if you have the rods, if you have this, or this, it's from the rod. And if you have one coming like this, it is a muon produced by
Just that one there.
Yeah, yeah.
I've done this with my A-level students.
Yeah.
Your rod's gone crazy.
Yeah.
Yeah.
Oh, this is absolutely mental.
Yeah.
Oh, that is great. Possibly.
Yeah, this is sealed very well.
Whoa.
This is a good.
I'm seeing with this one, it's sealed so well that that's really kicking off.
Wow. Better than. Ah, yes.
Are we seeing more now? Oh, yeah.
Yeah, that one.
Yeah, the
Yeah,
little
oh.
one.
Wow.
Yeah.
Oh,
Those are better, right?
huge.
Okay, everyone. What I would ask now, please, is... I realise I've overrun by 5 minutes on my section. I'm doing better for time than I thought. What I would ask us to do is this. If we could leave our cloud chambers where they are, if we could turn the lights off, please, for the cloud chambers. Sorry, turn your LEDs off for the cloud chambers, but leave your cloud chamber where it's